recording, so Francisco, go for it.
All right, excellent. Can everybody see the screen?
Yeah, looking good.
Yep, got it.
All right, perfect. So, in order to kind of get the presentation flowing and everything, I'm not really paying attention to the chat window on the WebEx meeting. So if you can use the Discord channel under events, I posted up the slides in PDF format there as well. And if you can just ask your questions over there, that'd be perfect. Right, so my presentation is called Join the Dark Side to Keep the Lights On. So I got interested in the what happens after a hurricane, right? So after a hurricane, you're going to lose power. How long are you going to lose power for depends on your area, your house. I mean, a lot of factors, right? But essentially, you can safely more or less know that you can be without power for a week or a month. I remember in the last hurricanes, specifically Katrina, I was out of power for about 2 weeks. So really hard time. You see a lot of people run over to Starbucks to get power, and your own little UPS power system would only last an hour ish, and then you don't have a way to deal with that, right? So even if you have a generator, right? Even with a generator, you have to constantly keep gassing that up, and when there's a hurricane, you have a huge crunch in that supply line as well. So I started thinking about, hey, how can I get a power wall, right? So what's a power wall, right? A power wall is going to be a home battery system, right? So over here, those are the actual power wall modules, right? And you can charge them either with the electric system or with solar power, right? When I made this presentation about 6 months ago, they were about $11,000 to install with the batteries themselves, right? So that essentially comes out to $846 per kilowatt hour, right? And this being a 13 kilowatt system. So I didn't really have 13,000, but it's probably going to be more because what the installation doesn't really include is a power switch that you have to put in between the grid and the battery so that the battery power doesn't feedback into the grid system when they're trying to connect it. But the goal for me wasn't necessarily to have my entire house running, right? I didn't want I wish I can have AC, but with this power system, yeah, you can probably have AC, but like 2 days. The point really was to keep the lights on, because during a hurricane, if you can keep the lights on, maybe turn on a TV, maybe keep the fridge on, you're really ahead of the game at that point, in my personal opinion, right? So before I really start going into all of the batteries, this is definitely a do at your own risk type of thing. I'm not an expert in any way, shape, or form on batteries or power or like the nitty gritties of electricity, like the previous talk we had. So definitely read the DIY battery book first. This is huge in avoiding and managing this type of risk, right? So what type of risk are we talking about? So a couple of years ago, the Samsung Note came out. and you saw that they were causing fires because people were left their phone inside of their car for a bit, and then all of a sudden those battery packs just went up in flames. And the chemistry that we're going to be mainly dealing with is going to be lithium ion. We're going to be talking about lithium ion because they're more or less the standard for high power and low weight batteries, which is really kind of like the best combination. All right, so let me know if the video doesn't come out as great, but
amps.
How powerful can these batteries be? So this is 6 batteries in parallel, and you can see that that's a wrench that's being heating up, almost being used as the heating element. So you can get a lot of power from these batteries, right? That's definitely something I really wanted to get across. You can run a lot of power, and you can cause a lot of damage at the same time. So definitely be aware of that. All right. So what can you use this power for? You can use it for emergency power. You can use it for camping. All right. Collecting solar power. You can use it for tailgating or mobile power. So if you wanted to go out to a game, you can build a battery enough to power boombox or an extra TV, or really whatever the case may be, because since we're going to be using lithium ion batteries, it's not like you're hauling a car battery worth of power. If you were to carry the same amount of weight from a lead acid battery as a lithium ion battery, you just have so much more power condensed into the lithium ion that you can do a lot more with it. All right. So how to make a battery? We're going to be talking about the just basic battery knowledge, enough to kind of be able to get you started with it. We're going to be talking about sourcing the 81650 cells, which are the batteries that we're mainly going to be talking about, soldering the power blocks to the PCB boards, and how to actually use the power that we get from the battery that we're going to build. All right, so basic battery knowledge. We're going to be talking about volts, amps, and watts. So voltage, which is this guy right here. The current in amps, which is the power output that you get here. The resistance, which is going to be the ohms, and then finally the power in watts. So a really, really good chart to get if you decide, hey, this is good talk. I've been looking for something like this, is this little chart right here. If you just Google Ohm's law, this is one of those power converters that really pops up a lot. And why is this important? Well, if you take a look at your regular phone charger or at any power block, power supply, it's going to say output, right? And the power output is usually going to say, hey, this is going to be this power charger outputs 5 volts at 3 amps, right? So when you multiply 5 volts by 3 amps, you get the power output of that charger. So what that means is you're pushing 15 watts of power into that battery that you're charging. So when over the years, as you start collecting more electronic stuff, you start collecting a lot more batteries and a lot more power inverters. And essentially you end up with a box full of junk that you can no longer use. After learning how power works, and even at this basic knowledge, I'm able to actually reclaim some of those systems and repurpose them later on. So this is such a good example of being able to grab knowledge in order to repurpose things that you otherwise wouldn't be able to use, right? So I really like this picture because it definitely really helps you kind of understand a little bit more of how these identical, how each individual thing comes into play. Right. So if you ever get confused, go back to the slide, and it helps visualize things a little bit better, which I definitely always find useful. Right. So we're talking about here. We're going to be talking about batteries in series. So batteries in series is usually something that if you ever connected a battery into, like the AAA batteries, into something, and you had to put them one up, the other one upside down, one up, the other one upside down, that's usually because you were connecting the batteries in series. So in this example, all right, inner series batteries of like voltage and amp hour capacity are connected to increase the voltage. So whenever you hear of batteries in series, you always have to think at the volts, right? So over here we have 4 batteries that are 12 volts each. When you connect them inside of a circuit, all right, and what's, again, in series means that you're connecting the negative to the positive, the negative to the positive, the negative to the positive, all the way until you complete that circuit. It's really important. Right, so we're adding 12 volts plus 12 volts, 24, plus 12 volts, 36, until we get the final 12 volts, which is going to be 48. Right. The next way that you can connect batteries together is batteries in parallel. Right. That means that you're going to be connecting the positive to the positive and the negative to the negative. All right, so connecting batteries in parallel increases the total current capacity by decreasing total resistance, and it also increases overall amp hour capacity. All batteries in a parallel bank must have the same voltage rating, right? So that means that if you're connecting 2 of these batteries in parallel, all right, they have to be 3 volts, and this battery also has to be 3 volts. All right. Everything has to be pretty much a copy of all the batteries have to have the same capacity. They have to have the same rating. It's really important for this to work, because what happens is, for example, if we had this battery at 3 volts and we had this battery at 3 volts, but we had this battery at 4 volts, when you connect this to actually extract the battery, right? So, for example, let's say you're charging a phone. The battery with the most capacity is going to be the one that's going to be supplying most of the power. So let's say you've charged your phone for about 15 minutes. This battery is going to be completely depleted in comparison to these batteries, which would have barely been used. So in order for everything to be charged and discharged at the same rate, they all have to have the same capacity and the same specs, right? So these are a few examples of what to do and what not to do, right? So over here we have an example of batteries connected in parallel. So this is a 6-volt battery with 4.5 amp hours. 6-volt battery, 4.5 amp hours, and remember it's parallel, so we're going to be connecting the positive to the positive and the negative to the negative, right? So since we connected it in parallel, that means that the amps are going to go up. So we take 4.5 amps and 4.5 amps, and we're going to get a total of 9 amps. And because we're connecting them in parallel, the volts don't go up. So this is still a 6-volt battery. It's still 6 volts, and we only have 6 volts here. So an example of how not to do it is right over here. So we have a 6-volt battery with 4.5 hours, and we have a 6-volt battery with 10 amp hours. So because of this mismatch in amp hour rating, all right, this type of setup is going to work, but you're going to overuse the 10 amp hour battery before you use the 4.5 amp hour battery, and it's just not going to turn out well. This is partly how you get the overcharge in lithium-ion cells, because since they're taking all like the majority of the power is only coming out of one cell, they're going to get hotter quicker, and the hotter they get, the more if you almost think about it like a nuclear reaction, where if it gets too hot past its safety rating point, it's just going to go into that nuclear reaction, and that's how you get those cells to explode and burst into flames. And once you get one of those batteries bursting into flame, good luck putting them out. And that's really how, what you're trying to avoid. Um, and that's what a lot of people don't necessarily pay attention to. Sometimes they just see, oh, this is 6 volts, this is 6 volts. I'll be able to connect the both of these batteries together, and that's incorrect. All right. Over here, we have an example of batteries connected in series. So this is in series, so we're going to increase the voltage of the battery. So this is 6 volts, 4.5 amps, 4.5 amps. We're going to be connecting the negative to the positive, and we're going to be over here at the power source is where everything gets connected. So we're increasing the 6 volts to 12 volts, and then the amperage of the batteries stay the same. All right. Over here, we have the same example where the batteries are connected in series, and they're connected in series properly, where we have the negative connected to the positive. But because the batteries are not in the same spec, this is 4.5 hours, this is 10 amp hours, it's going to work, but this is where you're going to do it wrong. The battery with the most capacity is the one going to be handling most of the load. All right. Now, there's a way that we can get both higher voltage and higher amperage inside of these batteries. So that means that we're going to be connecting a total of 4 batteries, and we're going to be connecting them together, right? 12 volt is a very common voltage. For example, your car runs on 12 volts. All the accessory power that you're pulling out of your car inside your car is going to be running at 12 volts, right? If you needed more power than that, well, really wouldn't be able to get more power than 12 volts because your car battery itself is a 12 volt battery, unless you're running trucks. What you want to be aware of is, since we have 4 6-volt batteries, we want to be able to connect them all together to get that 12 volt circuit. All right, so we're going to be connecting batteries in series, because remember, in series we get increase the voltage. So we're going to get 6 volts plus 6 volts to get those 12. All right, so over here, these batteries are actually connected first in parallel. So we have the positive to the positive, the negative to the negative, all right, which is going to give us the 9 amp hours. All right, and over here in this section, these are also connected in parallel. So positive to positive and negative to negative. Okay. Now this negative power volt is actually connected to the load, as is this one on the second battery that we're grouping. So really think about both of these 2 batteries as group 1 and group 2. All right, group 1 and group 2 are connected in parallel, giving you the 9 amp hours. And then when you connect both of these group 1, here's the positive, all right, to group 2, to the negative, all right, and then we have the negative being connected to the positive over here. That's what increases the total output of this battery to 12 volts and 9 amp hours. All right, it's not going to be 6 plus 6 plus 6 plus 6 because it's only 2 batteries that are actually connected in series, right? And those 2 batteries are group 1 and group 2. The second you create the parallel connection here, again, you're grouping the batteries. So it gets really convoluted and strange if you don't map out the batteries itself. But that's one of the reasons that we're going to be talking about these PCB ports that pretty much do all this type of series and parallel connections for you. So you don't really have to think about it, but it's really really important for you to understand why that PCB works in the way that it works, how it actually gets to that amperage and that voltage rating, right? So what you really have to understand about connecting batteries together, right, is that they all have to be balanced, right? And by balanced, I mean a 6-volt battery. If you're connecting a series of batteries in series or in parallel, you want to make sure that they all have the same specs. All right. They all have to be either 6 volts or they all have to be 12 volts. They all have to have the same amp hour rating. Because if not, that's where one battery. If one battery is the one with the highest spec, then that's the battery that's going to be doing the majority of the work, and that's the one that's going to be your weak link inside of your battery pack. So the batteries that you have everywhere is usually these batteries, right? They're almost like 3 times the size of a regular AA battery, and it's what you're going to be seeing everywhere. Inside your laptop, you have these batteries. Inside your power tools, these are the batteries that are going to be inside of those battery packs, right? So once you understand that, the reason that my laptop battery that I bought 6 years ago, the reason that those batteries no longer work is because these batteries are completely gone. So you can buy a new battery from the manufacturer itself. It's going to cost you $50, $80, depending on the battery capacity, or you can buy 3 of these batteries, which is usually what's included inside of your power pack. Reconnect them together, and you can do it for $15 instead of $80 or $50, right? So why are they called the 18650 battery? 18650 batteries are lithium batteries. It's really important that you understand the chemistry that you're working with. This is lithium ion. All right, they get their name from their size, which is 18 millimeters, right, by 65 millimeters. What does the 0 stand for? I don't know. These batteries are not only used in flashlights, but also in power tools, electric vehicles, vaporizers, cameras, laptops, and more. On that note, like what a Tesla is made out of is a whole bunch of these 18650 batteries. They just made their own battery, which was released back in December. But all those Teslas that have been on the road for 3 years, these are the batteries that they're going to be taken out. And that are going to be recycled out and available to the general public once those people start trading in their cars and switching the battery on Tesla. So this is why this 18650 cell is so widely available and used. This is pretty more or less the standard for rechargeable batteries because of its capacity, its ease of use, and the completely wild configurations that you can do with them. Right. Again, so if whenever you're thinking about building this type of battery system, if you don't use these cells, again, you want to make sure that all these specs are the same for whatever battery you're building. Right. That includes the chemistry, diameter and length. Again, you're using the same battery, so you definitely want to pay attention to that. But the voltage nominal, so this is at full power, what the battery voltage is going to be. The charge voltage cutoff, so this at 4.2 volts is what you're going to be charging the battery at. So you need to understand, hey, how much power am I going to have when these batteries are fully charged? And you're also going to need to understand how to charge these batteries, right? And know when they're charged, which for this, it's going to be 4.2 volts, all right? So a really interesting thing of why you need to understand how these chemistries work is, even though these batteries are fully charged when the charger tells you, hey, I'm feeding it 4.2 volts, and that's where it's going to cut off. All right, the second you finish charging that battery, the most you're going to be able to pull, all right, the usable power out of that is only 3.6 volts, and then it's going to dip down all the way until usually the safe buffer zone is about 3 volts. So you only have zero point 0.6 volts to use. So something really important. Now, the discharging cutoff is 2.5 volts, but you don't want it to get here, because the second thing about this type of chemistry, lithium ion, is that the second it gets to 2.5 volts, if at any given point in time, all right, it gets to 2.5 volts, the battery capacity just went completely down, right? So if you're expecting to get 300 to 500 recharge cycles out of these batteries, but the way you get to 500 is not by ever discharging it to 2.5 volts. You maintain that by only discharging it to 3 volts, 2.8 volts if you want to cut it down, but never to 2.5. If it goes to 2.5 or lower, you just went from 500 cycles to 300. If you do it again, then you're only going to get 200 cycles out of it. So it's, again, this is the behavior of lithium ion. So that's why it's important to understand why lithium ion behaves completely different from your standard car battery, which is going to be a lead acid battery, which lead acid batteries you can discharge much lower, but even with those batteries, you're going to have different behaviors. All right. So I'm going to be talking about reclaimed batteries. So that means that batteries that came off of Tesla or batteries that came off of a scooter pack. So what's the difference between both of those? Well, so for new Panasonic 3.4 amp hour batteries, you're probably going to be paying $4.99 per battery, right? So if you buy 10 of those, you've already spent $50, right? In comparison to reclaimed batteries, and especially if you're going to start this off as a project, definitely take a look at the reclaimed battery cells. If you mess them up, it's not going to break the bank in comparison, right? So reclaim LG cells at 3.1 amp hours, you can get them for about $1.50 per cell. And I buy them in packs of 40 because that's what the scooter packs use, and those come out to 57.50, right? So you can buy 10 batteries your first time, or you can buy 40. So it's, again, choose your own adventure on that. The charger, before you even start your project, you have to put all the 186 battery cells in one of these chargers. All right, so this is a battery charger and discharger that tells you, hey, what it's first going to do is you're going to put all your batteries inside of here and then charge them all the way up. All right, and this is going to do it automatically. So once it knows that this charger is feeding 4.2 volts, that's the charging cutoff, it's going to start the discharge process, all right? And the discharge process over here, you can do different settings. And again, what I recommend is once the battery reaches 3 volts. So what it's going to tell you at the end of that, which takes hours, we're talking about to do once you start this process, the charge and discharge from a discharge battery, we're talking about 8 hours for every 4 batteries. So this is going to be a long-term project. And at the end of it, remember, it's going to charge the batteries all the way up and then discharge them all the way down. And at the end of it, what you're looking for is this number of at the end of the process. So this is going to tell you how much milliamp hours of power discharge the battery has. The reason that it's important for you to know what it actually has at discharge is because that's the actual usable power, right? So there's two different milliamp hour settings. There's the discharge rate and then there's the charge rate, right? And the charge rate is always going to be higher than the discharge rate. So you always want to make sure that you are checking the discharge rate. So notice how the discharge rate of all these batteries are a little bit different, right? So out of this one, you got 2.7 amp hours. Out of this one, you got 2.6. This is 2.7 and this is 2.7. So once you do this initial test, you essentially want to be able to label each individual battery as closely as possible. So I'm going to be putting all the 2.7 amp hour batteries together in one bin, and then the 2.6 I'm going to put it in another bin, because remember, it's all about having everything perfectly matched up. And because you're using reclaimed batteries, all of the batteries are not going to have the same power output. So that's another thing that you want to take into account. Even though you buy 40 batteries, it doesn't mean that you're necessarily going to be able to use 40 batteries for your system. You might only be able to use 20. You might be able to use 30. It's really all up in the air, right? But you can use them in different capacities, different projects. So definitely be aware of that. I included a link to the charger there. That way you can get it if you decide to follow up with that project. Yeah, perfect. So this PCB board is a custom-made PCB board that this community has crowdsourced together in order to not even deal with, hey, I need to get X amount of power out. How do I connect batteries in? How do I know that I did the series connections properly? How do I know if I'm messing this up or not? And this is a really cool project. So essentially, this is a full DIY kit. So these are the battery holders. The PCB board is what actually has all the electronics to keep everything together and take the power of 7 batteries. Yeah, 7 batteries, 1, 2, 3, 1, 2, 3, 4, together in order to output 24 volts of power that's usable, right? And then over here, these little soldering points, we'll take a look at the video in a second. These are actual, oh man, what do you call that electrical box at your house that shuts off the power? This almost acts like a breaker, so that if at any given point one of these batteries starts pulling too much power or pushing too much power, these breakers kind of they're made out of only one wire. So the second that one wire burns up, boom, that battery is completely taken out of usable power, and this is one of the ways that it eliminates the risk involved in being able to use these cells. If you ever oops, this is one of those things that really saves you because it'll automatically take that battery out of series. And as long as you have to have a monitoring system in order to know, hey, one of my boards just went out, so let me take a look at this. Right, so really cool project. I did a lot more soldering because of this, and over here, they teach you how to get these battery holders, put them in the back, and start putting in the soldering tape together. Before you do that, there's a 5 amp fuse. That's a surface mount soldering. That's that's kind of a little bit harder to use. All right, these are the small little wires that I told you about. So they're already printed into the PCB. So if at any given point the first battery position here started pulling too much power, this tiny little cable would actually just burn up. And then any power that's coming out of here wouldn't go into the overall PCB. So you would uh, drop from 24 volts that these batteries are connected in automatically down to 21 volts, and you wouldn't have as much power output, but it would save that battery from going nuclear and starting a fire. So again, that's one of the reasons that we really want to use these boards. So another reason that I like getting things from this place specifically is because um, it already comes with all these videos. So if you don't understand, if you get the PCB board and you're like, great, excited, now what? The videos are there for you. So again, really easy. So I always like to use the crawl, walk, run method in a lot of these things. So this is what a PCB board that's fully connected looks like. This is what the 18650 cells look like. There's 7 cells and they're connected in series, right? The price of the kit, and the kit comes with the PCB board, these cables here, this battery voltmeter here. It does not come with this. You have to get this yourself. Amazon, I think it's like 12 bucks. So the total price of this kit, as you see it, really comes out to 23 volts, $23. You're pushing 24 volts of power at 3 volts because each individual battery cell is approximately 3.6 volts. When you multiply that by 7, that's how you get your extra 24 volts. And the final power output of it is, again, going back to our ohms first graph, is you figure it out by getting 24 volts of power, right? And that's what you're pushing out of these 2 little slots right here. 24 volts of power at 3.3 amps, which is, again, because we haven't connected these batteries in parallel yet, you're only going to get a total of 3 amps out. So you have a total of 72 watts of usable power, right? And the one thing, there's a couple of things that we're missing here, right? We're missing the charger, and we'll talk about that in a second. And this is being used more or less as the load. All of this is DC to DC power, so there's no conversions being used here. So this is really more or less like the battery cell phone chargers, the extra battery chargers that a lot of people have. So can you get them for cheaper? You can absolutely get them for cheaper. That's not the point. The point is you're building it, using it to understand the concepts of what power capacity is and how those systems work. So once you build one of these and you're in the market for another one of them, you can actually buy them out by spec and not necessarily by which one looks the prettiest. So again, really, really good things to understand, right? So the walking section of this is when you connect 10 of those PCB boards together. And we said that one of these PCB boards is 24 volts, right? Because you have 7 batteries connected in series. Then, like in the previous examples before, that every PCB board counts as only 1 battery, right? And then the rest of them are being connected in parallel. So you're increasing the amperage, right? So even though the voltage for each individual board is 24 volts and 3 amps, now you're multiplying 3 amps by 10 boards because all of these little copper connectors, those are connecting the batteries in parallel. So that's how you're able to increase your final power output from the 24 volts that each battery has You multiply the 3 amps by the 10 boards you have, so that's 30 amps. So you have a final battery that gives you 720 watts. So we're almost up to a kilowatt hour with 10 of these boards. So that's one of the things that we want to keep in mind, because again, the entire point is being able to make the battery, and then how do you use the battery, right? So once you check your cells, charge them up and discharge them, so you can group them up and put them into the PCB board with all of them having 2.7 amps of available power at the discharge, right? Or 2.8. You want to put all the like-minded batteries in the same PCB board. So once you do that, then you're gonna need a charger to actually charge this entire banking system, because you just made the battery. You didn't make all the other components to build with it. So what's missing out of here, that doesn't come inside of this kit, is the charger for the lithium-ion batteries. And again, we're going to go over that a little bit. Let's pretend this is a battery management system, which actually takes the input of this charger and redistributes it out to each individual board here in a balanced manner. That way, you're not just charging this PCB board, wait for it to get filled up, and then this board, and then this board. No, this BMS charges everything all at the same time. All right. So again, we cannot stress the point of this needs to be perfectly balanced all together at the same time, because this is how it works. It's either all working or none of it is working. Because the second you get unbalanced, that's where you get into those runaway scenarios where the batteries where one battery starts doing all the work, and that's where you're gonna have a bad day, right? So what the other thing that's also connected into a BMS power supply is that power inverter, and this is what you're actually going to connect your telephones, your light bulbs, whatever is using standard AC power connected to it, right? And then eventually, the next slide is going to be the running slide, right? And this is where you're actually putting multiple kits together. So this is a 30 PCB board kit. So this is where you're connecting 30 of those kits together. And again, each individual PCB board is 24 volts. That doesn't change. You're stacking them almost like Legos, which is really, really simple to do. So this is such a cool project, because once you understand that you can make one board, all right, in order to increase the power capacity, all you have to do is stack them up together like a Lego, and you have more power. And then you just repeat the same process again. So it's one thing you have to learn, understand, and get right in order for you to start scaling up until you get a huge monster like this, right? So this is 2.1 kilowatts of power, right? So each individual board is 24 volts, all right? These are 30 PCB boards, so it's going to be 30 times the 3 amps of power that seven batteries in series provide you, which is equal to 2.1 kilowatts at $342 per kilowatt hour. So how do we get down to this 342? So the battery kit itself is 419, 210 cells. So of those reclaimed scooter batteries are going to be $330. So it pretty much comes out to $100.43 per cell. So the total power of the total price of the batteries that you're going to be placing inside of this, plus the PCB boards and connectors, is going to be $720. So when you divide that by half, it equals to 342. kilowatt, $342 per kilowatt hour that you're going to be using. So now when you're using a system that's this big, you want to increase your charger, and also this is really more where you're actually getting a lot closer to a Tesla battery at this point. So this is where by this time, hopefully you did a lot more testing, know and understand how these batteries work and how much load you can actually put on them. And again, the battery by itself isn't going to do anything. You need to be able to connect a load to it. So this is going to be a pure sine wave inverter, which is really important for modern electronics. If you were to connect a TV, for example, and it wasn't a pure sine wave inverter, you can burn that TV up because of the non-regulated power that you're feeding to it. So it's really important that when you're looking at inverters, that you get a pure sine inverter. Really, really important, right? And then this is a much bigger battery bank. So there's a hack to use 2 HP server power racks. These are like anywhere between 800 watts to 1200 watts, depending on the model that you get. So you can charge this entire battery bank in 3 hours in comparison to using this battery bank charger, which is only 72 amps of power. And we'll cover that in a second in a little bit more in-depth detail. But again, what I really want you to understand is that once you build out the battery, you always need a way to charge it, and you need a way to use that power. So inverters. There's 2 types of inverters that I found that make the most sense. This is just a pure sine wave, pure sine inverter. This one specifically is for taking in 24 volts, right? And because our PCB boards are outputting 24 volts, this is the type of inverter that you're going to need. So this is a 2000 watt inverter. So at any given point in time, you can pull 2000 watts, and as long as the batteries can handle that type of discharge rate, this will give it to you. What takes up 2000 watts of surge power at a time? This is where we're talking about the actual air conditioning systems, or a washer, dryer, those types of electric motors that take up a lot of power. This is really more what you're going to be using, right? This is an all-in-one. So this type of power inverter is really cool because you can connect this to your battery system, and this already has the battery management system associated with the chemical battery that you're using. So if you were using car batteries, you can set up in the settings, hey, I'm going to be using lead acid batteries, and this will charge your battery bank by the specific amount of power it actually needs in comparison to overcharging it and causing a fire. So these are really cool systems, right? It also has the grid tie into it, so you can charge your batteries by the grid, or if you had a solar array, you'd also be able to put in that type of power into it, as well as a generator. So if you ever fell into that situation where a hurricane blew through and you needed power, this is the way to get that information out. All right. This is a basic diagram of how that battery system starts working, right? So specifically when we're looking at a system like this that already comes integrated, right? The charger is always charging the battery, right? This isn't connected because as long as this is on, that this type of battery system knows that it doesn't need to use the battery, so it doesn't cut off this circuit, right? The second that that type of system, integrated system, notices that there's no more power coming in, so there's no more charge. All right, the battery automatically completes its circuit to the inverter, and this is essentially how your standard UPS works. And now you really understand it and have a little bit of a better sense of how you can incorporate the system, either to make your own mini UPS power system that can last, instead of an hour, it can last 8 hours, 24 hours, or create a whole power system to create your own little Tesla battery. So using power inverter changes DC current, DC power from a battery into a conventional AC current, which is alternating current that you can use to operate all kinds of devices. AC current is what you're going to use for most devices: radios, power tools, microwaves, kitchen appliances, for example. And then those power inverters do their own DC power. So something that you have to be aware of. This is the reason that you have to use an inverter when you're plugging in a regular appliance. You can't just connect the battery to that appliance unless you know for a matter of fact that this is DC power, this is DC power, and this is how I can send the power over to that device, right? Inverters function by using a unidirectional DC power source to mimic an alternating current power source. Electronic inverters are essentially oscillators that rapidly switch the polarity of the DC power source, which effectively creates a square wave. A pure sine wave inverter is always needed for a grid-tied system. It's generally needed for power LED, TVs, CFL, light bulbs, and inductive loads like brushless motors. Clocks and audio equipment will behave much better on a pure sine wave. All right, so again, pure sine wave is really what you're looking at. There's other inverters that don't give you that pure sine wave. Those are going to be a lot less expensive, and there are such things that they say simulated sine wave, which means that they're doing their best to give you a sine wave, but it's not really a pure sine wave. So again, be very attentive if you're ever looking at inverters and it says simulated sine wave. That means it's not a pure sine wave. Battery chargers. So we were talking about battery chargers before because out of every battery, you're going to need a way to charge it. So the battery charger that you get is going to be dependent on the battery chemistry. Learn what chemistry of battery you have to pair up. All right, you always have to pair up the right chemistry with the correct battery, right? So the most common batteries are lead acid, nickel, cadmium, nickel metal hydride, and lithium ion batteries. Lead acid battery charger cannot charge a lithium ion battery charger. All right, so really important because the chemistries of each individual battery have different behaviors. So this is all covered in that book. I would have never known what the difference is or why it would cause a fire had I not read that book. So again, highly recommend you read the book. All right, overcharging can cause a fire. That's another way that you're gonna have a bad time. And again, pair the charger for the battery configuration that you're using. I included two chargers here. This is a 58.8 watts of power. So we get that again by multiplying the volts available in output. All right, this is outputting 29.4 volts by 2 amps. All right, giving us a total of 58.8 watts of power. So you can use this to charge the walk or the crawl methods of batteries. It's going to take a lot longer to charge a system like this, but again, if you're just starting out, this is like a $30 battery charger. And if you actually start looking at how much battery chargers are for this type of experiment, they can get stupid expensive. You see chargers for lithium ion batteries up in the $300 range. And if you ever have or have dealt with an electric bike and its charger, you know that those chargers are anywhere from 150 to 200 bucks. It really gets weird. So this one's like 30 bucks and it'll charge us, right? And this will give you enough power to maybe a day of backup power, depending on what you use it with, right? So you'll definitely be able to charge your laptop a couple of times. You'll definitely be able to run a TV for, let's say, 8 hours. So again, it's really being able to run your core critical systems. Like I know a couple of friends that have fish tanks. And if you ever start like a serious fish tank, you've invested thousands of dollars into that. So this is one of those systems that you can use in order to keep like an aquarium running for 5 days if that's how long you lose power for. So definitely something that you can use in that type of capacity. I personally just want to keep the lights on. So if I'm able to, if it takes me a week to charge this type of battery system, this will actually take more like 2 days to charge fully. But I can use that power for a week because I'm only using it to turn on the TV maybe once an hour, for 1 hour every day, and then I use the rest of that power to keep the lights on in the house. It's gonna go a long way. Right. These are this is another hack that you can do, right? So server power supplies are anywhere between 800 to 1200 watts of power. And there's a way to use the full 800 or 1200 watts. This one gets a little bit, so what they did here is they actually took a look at the schematics of these power supplies, and then they jumped these pins so that when you connect the positive and negative cables of this, you can actually just pull a straight up 800 watts at all times. This is really what so you can buy these power supplies for about 50 bucks. So it's definitely a way to save money on the power chargers. But again, a lot more risk that is involved to it because you're talking about handling a lot of power with this. But this is what the community as a whole is recommending. This is what they're doing. There's plenty of videos that you can read about and use. But yeah, this is really where it gets more to the scary part. I have these, but I haven't like connected them in series or done the jumpers yet, just because I don't feel as comfortable yet. I want to be able to like do a full long-term session with these before I go just like full ham in the beginning. All right. So in the event that you don't want to solder two power connectors from a power supply this big, they have these inverter, these connectors right here that automatically reroute that power that way. So I think these are like 50 bucks each. A little bit more expensive. It'll bring you the overall cost to of these chargers to more of the $200 range, but it doesn't matter because again, if you don't feel that comfortable, 200 bucks in comparison to burning up your house, small price to pay at the end of the day, right? So this literally just slides on to the power supply blades right here, and boom, you're ready to go as soon as you connect your cables to this, your positive and your negative. Boom, you're ready to go on this. Right. So again, this is why this is an example of how you would pair up the correct charger. So we have two power supplies. These would be connected to the battery. But again, in between the battery, there's a battery management system that you're connecting this to. That's the one that actually handles the input and the output of the power to charge everything at the same time because you're using all the batteries at the same time. You're not using just one blade or two blades. You're using all of them, right? BMS. So BMS, this is what they look like. These are the battery management systems. This is what controls the balance charging of each individual device. So for the way it's working here is that you have, remember, each PCB board, you have to think of it as one battery. So 24 volts, 24 volts, 24 volts, 24 volts. And all of that voltage is going through the same connectors right here. What's increasing the amperage is because these are connected in parallel. So if you notice, this is the negative and this is the positive of each individual board. And again, it's the same thing over here, negative and positive. And all of these connectors are copper screws that get connected together. And that's how you have the parallel connection. And while all the batteries in each individual PCB board are connected in series. So these PCB boards make it incredibly simple for you to just set it and forget it. You can come in, pop in the batteries, connect them up, and just increase the power capacity there. So what's the point of all this? How do we get to battery? How do we actually use the power that's involved in there? So I like to think of it as 1 kilowatt. So this is where you take a look at your TV and you connect a kilowatt power meter to figure out, okay, hey, my TV takes 30 watts of power while it's on. So per hour, right, it's only using 30 watts of power, right? So how long until it gets to 1 kilowatt is how much usable power I'm going to have, right? So a kilowatt, otherwise known as a kilowatt hour, is a way to measure how much energy you're using. It's not the number of watts that you're using in an hour, even though it seems like that would make sense. A kilowatt hour equals to the amount of energy you would use by keeping a 1,000 watt appliance running for 1 hour. In metric, 1,000 equal to kilos, so 1,000 watts equals to a kilowatt. For instance, if you turned on a 100 watt bulb, it would take 10 hours to use 1 kilowatt hour of energy. A 2,000 watt appliance, on the other hand, would only take half an hour. And it all comes down to dividing the number of watts in an appliance into 1,000 to get that kilowatt hour. So this is a chart that I got that more or less tells you, hey, if you create a battery that's 1 kilowatt hour, which is more or less the baseline before you start getting into the big stuff. This is more or less how much you would be able to how much usable power you'd be able to get out of it, right? So large TV like this with 1 kilowatt hour power, you'd be able to run for 11 hours. An Amazon Echo 330 hours, a ceiling fan 16 hours. So if we're talking about a hurricane scenario where all of the power is gone, this is more or less what you should expect to get out of that battery before it runs out of juice. So that's the overall goal. It's in order to get the charger connected to the BMS in order to properly maintain that battery connected to the inverter, and then use it, connect that inverter over to the light bulb, to the TV, to the fan, to whatever load you need to power. Building out a DIY lithium ion battery will allow you to have a UPS for the entire home. And again, it's scalable, right? So in comparison to the Tesla Powerwall, you're not putting in a full $13,000 into a system like this. You can build it out a kilowatt per year. So if you have a home, imagine you're spending $1,000 every year in order to increase that power. By the end of 5 years, you already have 5 kilowatts, which will be enough to actually survive more or less pretty comfortably in an event where you are out of power for an extended amount of time. And again, that always leads you up to the ability to hook up more solar arrays into your home, right? I found this project really, really great to increase your hardware skills and start working on more hardware related projects. What it actually came down to was once you understand what the power requirements of an electric device is, then you can start looking at the PCB board, like something as simple as a Raspberry Pi, right? And start figuring out, oh, the reason that it's a Raspberry Pi is using 15 watts of power is because this processor is using 10 watts of power. And then all these other little components for the LEDs and everything else take up another 5 watts. So you start tracing that, you start figuring things out for sound systems, really, really cool. You figure out how to replace laptop batteries, replace old power tool batteries, which is really a huge plus because lithium ion batteries, when you buy them brand new, again, super expensive, but you can cut down your costs if you understand how the entire process works. And again, these batteries are in so many more things. There's projects that allow you to turn old laptop monitors into portable monitors, which is always a huge plus. Projects that allow you to create your own Bluetooth amplifier. So instead of buying another UE boom, you can make your own UE boom and just repurpose everyday old electronic stuff. Um, I did this presentation about 6 months ago, and then over Christmas, some of these things went like severely lower in price, right? And what we have here is an integrated system that does everything for you. All right. These come out to $350, but it's everything in a small form package ready to go. Right. It already has all of the batteries integrated into it. You can charge it with a car battery, car cigarette lighter here. You have 3 outlets ready to go. You have a fast charge port. You have other USB ports. You have a USB-C port in order to charge USB-C devices at a rapid charge. It's 288 watt hours of capacity, right? So, for example, if you're running a fan, right, that uses 30 watts of power, you can run that for about 8 hours using one of these. You can charge multiple laptops. So this is a really cool device that includes all of the knowledge that you just gained and gives it to you automatically. And you can also charge this via the grid. So just by plugging into an AC outlet, you can use solar power out of it. And you can even just, again, charge it with your car. BMS is included into it. The pure sine wave inverter is already included into it. So this is a really nice way to get into the project. And again, even if you don't want to deal with having a generator, right, during a hurricane, that'll cost you about $500. This is 350. You spend another 200 bucks and get the solar panels connected to it. And now, in the event that a hurricane comes through, you'll be able to power again small devices. You can power a TV for a couple of hours and then recharge it the next day with solar power without having to worry about gas shortages or anything of that sort. And if you have a drone, right, and you want to take it out to the park, like this is what you want to use in order to be able to recharge those batteries. If you're going camping, this is amazing. Tailgating, again, this is super cool. And these are all the parts lists that are I included. The DIY battery book, again, super big requirement for sure, without a doubt. I wouldn't have I probably would have burnt down something without me reading this book before. I know I was taking out some drone batteries, and those come in lithium ion pouches. And by mistake, I was using some tweezers to take out a connector, and I connected the tweezers to the negative and positive of it, and they like lit up immediately, like within less than a second. And instead of two sharp ends, I had two bulbs at the end because that's how quick and how much power these batteries have. So you definitely don't want that learning curve. This is where to get the lithium ion battery packs, right? So they're going for 5750 per 40 cell pack. The DIY battery kit. So this is where you get all of the PCB boards, all of the pieces, all of the connectors. The regular, the small battery charger, the big HP power supplies from the servers, a DC to DC regulator, that's what you're gonna need to use later on, a adapter, that's what you connect the server rack mount over to. That's what you connect, instead of soldering those two cables in the HP power supplies, that's what you would use in order to just completely bypass that power meter. Standard regular, hey, how much current am I pulling out? Just standard. This is a really great resource for the mobile solar power. Super good. This tells you about plug and play programs, do-it-yourself systems that already comes with parts, and that way you don't have to do any of the guesswork. This is where I got a lot of my graphics from. And if you're saying, hey, this is a great project, but I don't want to deal with the pain and the hassle of building a battery. I just want the battery and connect all the pieces together. There's a place called bigbattery.com where they'll automatically build the battery for you. This is made out of lithium something cells, but essentially the LiFePool cells are lithium ion cells. No, you know what? I'm lying to you on that. They're lithium based, but yeah, lithium iron phosphate battery. These are super stable. These batteries are the preferred batteries, the preferred chemistry, because you can't. They're really hard to mess up. Even if one battery is doing most of the work, the battery itself won't have that nuclear reactor where it's just gonna heat up, and then cause a fire. So this is one of those chemistries that comes automatically done for you. And this pack is 2.2 kilowatt hours, right? So for $1,100. So instead of getting it for 342, you're paying $500, but you didn't do any of the assembly and it's ready to go. So you hook this battery up to your inverter and your charger, pair it up correctly, and as long as you understand the concepts of it, you'd be able to get it. And yeah, that's it. Let me know if anybody has any questions.
Thank you very much for such a great presentation. Any questions? The slide deck.
Yeah, the slide deck is already in the events and in the presentation section of the Discord.
Also, I also posted it in Slack since the bot doesn't have copy file capabilities at the moment. So it's in Slack in the events channel, as well as in the Discord presentation files channel.
We also have a GitHub, and we saved it in GitHub too.
Oh, okay, cool. And I thought that presentation was awesome. I wish Francisco, you're buying a house and gonna do your own solar array on there?
I mean, it's definitely a possibility now. Like to me, it's a lot more accessible to be like, all right, I don't want to go in full 10,000, putting in $10,000 investment. If I want to just keep the lights on, let me get something with like 2 kilowatts. And again, be comfortable enough. I don't need to run everything, but having lights is huge when nobody else does. So that's my way of thinking.
No, that is completely true. It's very cool to do something like that, especially adding like making sure your internet connection stays up and a little FEMO tower to give you cellular service when the main towers are down.
Yeah, and I mean, I know a lot of people in this group use the CB radios, right? And you're gonna need power to transmit, and this is what will make sure you keep that power alive.
During the last hurricane season, when I was down in Homestead, not the last hurricane season, couple hurricane seasons back, when we got hit, it was and all the cell towers were down. My little FEMO tower kept us up, and I had people from around the community just roaming by my house and getting cellular signal. So it's pretty good to have, especially when we had power, but we didn't have cellular service, right? So everyone was still out of cell phone service. It's pretty
Yeah,
good.
and especially if you have kids, right? And you can, and they're out of school for a week, but you have your own Plex server and enough power to keep on a TV for 8 hours. That's 8 hours that you don't have to worry as much.
8 hours without having to worry about kids is is always great to have. Hey, Rod, what's next on our calendar for next week? Or do you want to open it up for any questions for the group chat, for just general questions?
Yeah, on February 6th, I'm going to be presenting about popular attack vectors against Telegram, WhatsApp, and Signal. So it should be interesting. Hopefully, all you guys can make it. Other than that, we welcome all your projects, suggestions, or research that you might need help. Or if you're looking for a job, there's a job offers or jobs channel where there's always new postings, and the industry seems to be doing very well. So if you need any help, or you want a reference, or you need to know somebody that work in a company that we may know, just let us know. Just join the Slack or the Discord, and I'll keep you guys posted on everything that's happening. And hope you stay safe.
I've also been at work. We've been doing a lot of reverse engineering and messing around with some malware stuff, and I've been posting a lot of some tips in the reversing channel on Discord, like a bunch of little projects. We've been going through a bunch of the Pwn.college. They also have a Discord channel, and to ask questions, if you want to ask questions in that channel, or want to do any of the reverse engineering with me, I'm on actually level 7 right now. Still working my way through Pwn College question set. It's like a CTF style. They have it with CTFD, so that you can keep track of. They have an educate learning chat level and then a test level. So one gives you a little bit of a directions and some hints, and then the next one doesn't give you any directions and hints. And basically, it's a lot of R2 and radar 2 and debugging. So it's great if you want to get your hands into learning some basics of CTF. I'm doing those. If anyone interested in wanting to go along with me and do some as well, I'll be happy to give some advice on the lower end challenges as I work my way up through them as well.
Yeah, on that note, we had another member that posted up the VX Underground chat that Miami-Dade Cyber Club was doing. That was a really good presentation. There's the actual malware samples in that website, and they have over 400 plus malware samples that you can download, like real malware. And since Respeto, you're talking about reversing things, that's a really good repository of new things and old things.
Yeah, after reversing a couple of pieces of real malware, and then we're just and so into it, and we're looking at it. I'm like, oh my gosh, I wish I could see the source code that generated this loop. It looks so ridiculous. How did who wrote this to make it do this? You know, it's always great to see stuff like that. In a debugger and reversing it.
All right, any other questions? Well, then thank you very much, and we'll see you guys soon. Thank you.
See you guys.